Welcome back to more of section 5.3. We're going to be solving number 14. Now, if you look, number 14 has sine and cosine in it. We can't work with that. Now, I can rewrite sine squared. I can't rewrite cosine. So what I'm going to do is I'm going to use my Pythagorean identities, where sine squared theta plus cosine squared theta equals 1. I'm going to isolate that sine. So I'm going to subtract cosine squared theta from both sides. So I get that sine squared theta equals 1 minus cosine squared theta. I'm going to substitute. So it's going to be 2. Now instead of sine squared, it's going to be 1 minus cosine squared x plus 3 cosine of x minus 3 equals 0. Distribute the 2. 2 minus 2 cosine squared of x plus 3 cosine of x minus 3 equals 0. So now, when we rewrite, we get negative 2 cosine squared of x plus 3 cosine of x minus 1 equals 0. Now, I don't want my leading coefficient to be negative, so I'm going to factor out a negative 1. So we get negative 1 times 2 cosine squared of x minus 3 cosine of x plus 1 equals 0. And you can divide both sides by negative 1. So you get 2 cosine squared x minus 3 cosine of x plus 1 equals 0. Do a little substitution here. Let's say that the cosine of x equals y. So we have 2y squared minus 3y plus 1. So when I factor that, I get 2y and y. So it's going to be 2y minus 1 and y minus 1. So when I substitute back in 2 cosine of x minus 1 and cosine of x minus 1. Set each factor equal to 0. Cosine of x minus 1 equals 0. Cosine of x minus 1 equals 0. Oh, sorry, 2 cosine of x minus 1 for the first one. So we add 1, we get 2 cosine of x equals 1. So the cosine of x equals a positive 1/2. And for the other side, cosine of x equals a positive 1. All right, now cosine is positive. So I'm just going to use this side over here. Cosine of x equals 1/2. So it's going to be positive for cosine in quadrant 1 and in quadrant 4. So when it's a 1/2 for cosine, it's going to be at our pi over 3. So quadrant 1, it's a pi over 3. And in quadrant 4, it's a 5 pi over 3. Now for cosine of x equal to 1, that's going to be at a quadrant angle. And that's when we're at 0. That's when x equals 0. That's at a quadrant angle. It's on the, right there at where quadrant 1 and quadrant 4 meet. So if we're going from 0 to 2 pi, or 0, yeah. So we're going to have x equals, x equals pi over 3, 5 pi over 3, and 0. Those are our solutions from 0 to 2 pi, not including 2 pi, because that would be in the next unit circle. Now, in the general form. Now, pi over 3 is here, and 5 pi over 3 are here. They're not really nicely separated. So to get to the next angle, we just have to keep adding our 2 pi. So x equals pi over 3 plus 2n pi, 5 pi over 3 plus 2n pi. And our last one, actually, x equals, when it's 0, it's going to be at 0, 2 pi, 4 pi, same thing, keep going and going. So it actually can be written as 2n pi. There's our general form. There's all of the possible solutions. We're going to come back to number 15 at the end. Let's go to the next page, please. Here's functions involving multiple angles. Let's skip this one. Sorry, I'm all over the place. Let's skip and go to problem number 18. It's a very similar one to what we just did. I can rewrite secant squared. I can't rewrite tangent. So remember, 1 plus tangent squared theta equals secant squared theta. So instead of writing secant squared, 1 plus tangent squared of x minus 2 tangent of x equals 4. So I'm going to subtract 4 from both sides and then combine my like terms. So I get tangent square root of x minus 2 tangent of x, and then 1 minus 4 is negative 3, and that equals 0. Now, using our substitution like we did, let's say that tangent of x is y. So what we have is y squared minus 2y minus 3. So when you factor that, y minus 3, y plus 1. So when we substitute back in, the tangent of x minus 3 times the tangent of x plus 1 equals 0. Set each factor equal to 0. Tangent of x minus 3 equals 0. Tangent of x plus 1 equals 0. So we can add 3 to both sides, so the tangent of x equals 3. And for this one, tangent of x equals negative 1. Now, we can solve this. We can take the tangent of the inverse tangent, of any real number. So to do that, what we're going to do is we're going to take the tangent inverse, or the arctangent of both sides. So the arctan of the tangent of x equals the arctangent of 3. So x equals the arctangent of 3. Remember, arctangent is the same as the tangent inverse. They're equivalent. So there you go, the arctangent of 3. So that's about equal to 1.25-ish. And when tangent is negative 1. Remember, when tangent is negative, it's going to be negative in quadrant 2 and quadrant 4. When it's a 1, that's going to be our pi over 4s. So to get us in quadrant 2, 3 pi over 4, and this to get us in quadrant 4, it's 7 pi over 4. So now, our solutions. The exact solution would be the arctangent of 3. That 1.25 is a rounded value. 3 pi over 4 and 7 pi over 4. Those are our solutions from 0 to 2 pi. Now, for our general solutions, for that general form. Now, think about the unit circle. Here's our 1.25 radians. About there. Now, to get back to it, we're just adding another. Sorry, that tangent's positive. So what we're going to do is we're also be going to down here and track from quadrant 3. So what we could do for the arctangent of 3, x equals the arctangent of 3 plus n pi. And then for the 3 pi over 4, we're here, and 7 pi over 4 are here. Those are separated by pi. So we can write both of them and account for both as 3 pi over 4 plus n pi. That includes that 7 pi over 4. So there's our solutions in the general form. All right, let's go back to problems number 16 and 17. Here's our multiple angle ones. Now they work very similar. We're ignoring the 3t for right now. So I'm going to add 1 to both sides. So 2 cosine of 3t equals 1. Don't worry about the 3t. Divide both sides by 2. The cosine of 3t equals 1/2. Now, still ignore the 3t for right now. Cosine is positive in quadrant 1 and in quadrant 4. Now, to get us the cosine being a 1/2, that's at our pi over 3. So in quadrant 1, we're at pi over 3. And in quadrant 4, we're at 5 pi over 3. Now, if we think about this graphically, here's pi over 3, and here's our 5 pi over 3. They're not separated nicely. So for writing, we'll come back to the general form in a second. 3t equals pi over 3, and here's where that comes into place. 3t equals 5 pi over 3. To get rid of the t, multiply both sides by 1/3. So t equals pi over 9 and 5 pi over 9. There's our solutions from 0 to 2 pi. Now, for our general form. Here, like I said, they're not separated nicely. So we're going back. 3t equals pi over 3 plus, to find the other solution, 2n pi. 3t equals 5 pi over 3 plus 2n pi. And just like we did the last time, multiply everything by 1/3. So we get t equals pi over 9 plus 2n pi over 3. Same thing, multiply everything by 1/3. 5 pi over 9 plus 2n pi over 3. There's our general form solutions. The key there is you want to put that 2n pi before you get rid of the number in front of the variable. Let's try another one like that. So we're going to isolate, so subtract 3. So 3 tangent of x over 2 equals -1. Divide both sides by 3. The tangent of x over 2 equals -1/3. Tangent is negative in quadrant 2 and in quadrant 4. Now, when tangent is a 1/3, oh, excuse me, I lost my 3. -3 over 3. So that's when tangent, x over 2 equals -1. Now, tangent negative still, quadrant 2, quadrant 4. Now, for tangent to be a 1, we're at our pi over 4s. So something pi over 4. To get us into quadrant 2, that's going to be a 3 pi over 4. To get us into quadrant 4, that's 7 pi over 4. So now, x over 2 equals 3 pi over 4. X over 2 equals 7 pi over 4. To get rid of the dividing by 2, multiply both sides by 2. X equals, that's going to give us 3 pi over 2. Multiply both sides by 2. X equals 7 pi over 2. Those are our solutions from 0 to 2 pi. Now for our general form. Now, looking at these, here's quadrant 2. Here's our 3 pi over 4 and our 7 pi over 4. Those are nicely separated by n pi. They're separated by pi. So what we could do for general form is x over 2 equals, we'll just use one of them, 3 pi over 4 plus n pi. Remember, tangents separated by pi. That's why we're allowed to do this. Now multiply everything by 2. X equals 3 pi over 2, 3 pi over 4 times 2 is going to be 3 pi over 2 plus 2n pi. We had to multiply everything by 2. There's our solutions for general form, because adding that n pi included our 7 pi over 4. So there's both of our solutions. All right, let's do one more. And this is going to be problem number 15. And 15 is a little bit different than the other ones. So we're only looking from 0 to 2 pi. We're not going to worry about the general form. So now there's really nothing we can do here. So what we'd have to do is we'd have to square both sides. So when we square the cosine of x plus 1, remember that the cosine of x plus 1 times the cosine of x plus 1. So be careful when you multiply those. You get cosine squared x plus 2 cosine of x plus 1 equals the sine squared of x. Want to get everything on the one side. Subtract sine squared x from both sides. Actually, before we do that, I see sine and cosine. I don't want that. Now we know that sine squared of x plus cosine squared of x equals 1. I'm going to isolate the sine, so I'm going to subtract cosine squared of x from both sides. Sine squared of x equals 1 minus the cosine squared of x. So we get cosine squared of x plus 2 cosine of x plus 1 equals, instead of writing sine squared, 1 minus cosine squared. And now we'll isolate. So we're going to add a cosine squared to both sides. And we're going to subtract 1 from both sides. So we get 2 cosine squared of x plus 2 cosine of x equals 0. Now we can factor out a cosine of x. So it's cosine of x times 2 cosine of x plus, we can factor out a 2 cosine of x, even better. So that gives us a cosine of x plus 1. Now set each factor equal to 0. 2 cosine of x equals 0. Cosine of x plus 1 equals 0. Divide both sides by 2. Cosine of x equals 0. And cosine of x equals negative 1. Now, cosine of x equals 0. So cosine of x equals 0 at our quadrant angles. That's going to be when x is pi over 2 and at 3 pi over 2. And cosine of x is going to equal negative 1 at x equals pi. Now, there's our possible solutions. And I say possible because when we squared both sides, we introduced some potential error. We need to check for extraneous here. So when we do that, we always go back into the original. The cosine of pi over 2 plus 1 equals the sine of pi over 2. Now the cosine of pi over 2, that's 0, plus 1 equals, and now the sine of pi over 2 is 1. 1 equals 1, is valid. So pi over 2 is good. The cosine of 3 pi over 2 plus 1 equals the sine of 3 pi over 2 now. Now the cosine of 3 pi over 2 is 0. Plus 1 equals, now the sine of 3 pi over 2 is negative 1. We get 1 equals negative 1. That is not true. That is not valid. So the 3 pi over 2 is extraneous. And now let's check the pi. Cosine of pi plus 1 equals the sine of pi. Now the cosine of pi is negative 1. Plus 1 equals, and the sine of pi is 0. So we get 0 equals 0. And that's a true statement. So our only valid solutions, x equals pi over 2 and pi. Once again, we're only solving between 0 and 2 pi. That's all we need. We don't need to worry about the general form there. And that is solving these trigonometric equations. All right, thank you, and I'll see you in the next video.